Do you hear me? Okay, so let's start. So we have two identical instances, but one is performed much better than the other one. Well, how can it be? Well, I call it an AWS magic. But I will give you the solution during the presentation, don't worry. Okay, so I will talk about Vertica, what is the core concept of columnar database, how we use it in Convertro, and we'll talk about Vertica on AWS a little bit. So Vertica claims that it will give you 100x faster than other row store databases like Oracle, Postgres, or MySQL. Actually, when we checked it, we got to about 99x faster, so don't believe everything that the marketing people tell you. But seriously, Vertica will give you great benefits for advanced analytics, and it's best to explain it with a simple example. So we have table with two rows. Actually, it's a city table, so we have Tel Aviv row and the Dallas row. And when we insert those rows into a row store, it will go row by row or block by block. And you can see here that the Dallas row will span 3 blocks. And what you can see here is that the variety of the data is pretty big. So we have a lot of data types in one block. We have integers, we have dates, and we have strings. And the ability to compress them is not that good. Even if we duplicate those rows over and over again, we will not be able to compress the blocks. But if we see it as a column store, we can see that the continent column is one file or more file, and we have similar data on each file. On top of it, Vertica will also sort the data, and sorting the data will give us two benefits. One is that we can get very high compression rates, and most of the clients of Vertica will get about 70% decrease from Oracle or MySQL or another row store. And the second one is that if we want to see only North America, we will not need to scan the entire compressed file. We know, or actually Vertica knows exactly when North America starts and when North America ends. So we will scan only the North America rows. So this is the core concept of how column store works and why it gives us such an amazing performance for analytics. There's also other stuff, but this is the core concept. So how we use it in Convertro? Vertica has several different methods how to load data from Hadoop. We built our own Hadoop loader because at the time, Vertica HDFS loader was not that good. It was, I think, 4 years ago or more. And the other one is that we wanted to control every aspect of the load. So if you see on the left side of the slide, we can control how many parallel copies will be on the entire cluster. We can even drill down into one node and see or to control how many copies will be on each node. And on top of it, we can decide how big each chunk will be in size, like a gigabyte, or in terms of number of rows. So we can scale up or down based on our business needs or based on some client priority. And on the right side, it's a serial operation. We are doing some move partition, but it's very fast. So this is how we load to Vertica. Hydro is a smart topology layer that sits between the client and our data source. And Hydro decide for where we're going to get the data, how we're going to get the data, and what kind of a business logic we are going to do on top of this data before we return the result to the client. And it needs to be doing it in real time, so it needs to be very, very fast. And for example, the client here is submitted a dashboard query, and behind the scene, Hydro kicks in, and Hydro knows this client, so he knows the topology says, go to Vertica, do not scan the entire table, do a sampling on this table, then join it with result from MySQL, and then do some kind of a business logic because it's a very high priority client, and then return it to the client. A small story about Hydro. We have a big client, and a time to rebuild this client, the entire data was 27 hours, which was unacceptable for us. So what we did, we moved it to Hydro, and Hydro removed the complexity from the ETL and moved it to the front end or the runtime, but with a very small overhead. We only added a 0.02 seconds for each 10,000 rows for the dashboard. So a very small overhead, but on the ETL side, we decreased the time from 27 hours to only 9 hours. So Hydro is helping us not only on the front-end side, but also at the back-end side. And it's open source. You can download it from GitHub and use it. We use it and love it a lot. So I divided the AWS phase into 3 phases. One is the setup, its initialization, one time, the day-to-day routine, and what is our next step in Converter. So in Converter, we lived in the cloud Wild West, which is EC2 Classic. And as you can see, we have a lot of instances, several types of instances, and the problem here is that they all share the same resources. And if you have an issue with one instance, you need to stop and start it, which happens. You will never know where it will start, on which rack it will start, or on which placement group it will start. And more than that, if you stop and start an instance on EC2 Classic, you will get a new IP. And if you get a new IP, you need to reflect it to Vertica, which is not a nice process to reflect a new IP to a Vertica database. So if you remember from the first slide, those are the 2 identical instances, and I asked, how can it be? So Brandon Gregg, who is a senior system architect at Netflix, found this issue, and what he found is that one instance sits on the top of the rack, while the other one sits on the bottom of the rack. And the one on the top of the rack was very close to the air condition and got a very good airflow. So he was cooler. It was cooler, and once it was cooler, it got the Intel Boost technology, which says overclocking the CPU by 30%. So, and the instance on the bottom didn't get this Boost technology, so it was regular. So pretty amazing. It's kind of an AWS magic, and it's very hard to find it. Okay, so we moved to VPC, and VPC give us several benefits like enhanced security and some kind of a on-premise subnet. But the most important thing for Vertica is that once you stop and start an instance, you will get the same IP, so you will not need to do the big routine of changing IP to Vertica. But if we even drill down into one placement group, one rack, we can still see that we have several types of instances. And we want our instance to get the most throughput it can. So you need to choose an instance that is compatible with Vertica. Vertica loves fat instances with a lot of RAM, a lot of cores. So you need to choose this, and you need to choose an instance that has the feature of enhanced networking, so you will get a better packet per second and a lower latency. and you need to choose an instance that is EBS optimized. So you can see here that there are 3 instances that they are sharing the same channel or the same bandwidth to the storage system. But another one is EBS optimized, and it has a dedicated channel for the storage system. But you also need the disk to handle all this load. So what do you choose? You choose an SSD, you choose a magnetic one. Are you IOPS bound or throughput bound? You're using RAID 0, RAID 5. So Vertica documentation says that the recommended throughput is 40 megabyte per second per core. So even the best SSD that Amazon has will limit you to an 8-core instance to meet these requirements. So you will probably need to do some kind of a software RAID. We choose in Convertro to use magnetic, and we built a RAID 0 with 8 devices. But even with 8 devices, we are not getting to the Vertica requirements. Our luck is that we are not IO bound, but we still get hurt while doing a big recovery or rebalance the cluster. Sorry. By the way, we are changing today the type of the EBS, and I will talk about it later. So we moved to VPC. We picked the right instance, a very fat instance, a very powerful instance. We have enhanced networking, and it's EBS optimized, and we get the right configuration in the EBS or the storage. What we want to do is try to get all those nodes or Vertica nodes into one placement group, one rack, so they will get the most throughput it can get. It's not easy because Amazon will not guarantee that you will have space on the same placement group. So what you can do here is once you create a cluster, you create all the nodes in one shot and on one placement group. Amazon will try to make a space or to get a space in one rack. If it succeeded, good. If not, try again. But even if you get into the same placement group, you will still have an issue if you replace a node or extend the cluster with other nodes. So you cannot win here. So in your day-to-day routine in AWS, nodes will fail. Okay, and you have several scenarios for a failing node, and you need to automate the recovery process. So the most common scenario is that you have some kind of a magic network glitch in AWS, and a Vertica node leave the cluster. What you will do, you need to automate the restart of this node, and it will rejoin the cluster. Another one is that you cannot SSH into the instance. So you will need to reboot the entire instance, and if you're in VPC, there is no problem. It will rejoin the cluster. And another scenario is that the whole cluster went down, and then you need to recover the entire instance, and hopefully it will not be a lot of times. AWS Magic, again, some kind of resource glitches or degradation, and what you need to do here is to check on a daily basis your resources. And Vertica has several resource utilities for I/O, for CPU, and for networking, so check them regularly. And lastly, before the future, as I talked before, I said that we are changing to a new EBS, and I think last month, Amazon released a new type of EBS, ST1, which is focused on throughput, which Vertica loves. So we tested, and it's pretty good, and we are moving it. We are getting 3 benefits from it. One is that we are getting better performance. The other one is that we are removing complexity because we are not using RAID. And last one is that we are even able to reduce our cost. And replay database means that we want to record the activity from one cluster and replay it on another cluster. So if we have a new version of Vertica, we will record our production cluster and then replay it on the new version and see if it's better or worse, if we get an error or not. Even if we want to test a new feature of the application, we can do it. And lastly, cluster elasticity is something that we want to do. Instead of having a big development cluster that is idle most of the time, we want to have an on-demand cluster, dynamic cluster, which terminates when the engineer finished with his job. So instead of having a big cluster, we will have small cluster that will start and terminate based on the engineer's works. That's it. And do we have time for questions? No?
We could probably spare a minute if you want to.
You actually mentioned about the cluster, the host in the placement group, right? So you basically have a one shot of having everything in one placement group. And you also briefly mentioned if there's host failure, of course, you may get the host pretty much not close enough. So how do you deal with that actually in reality?
There is no guarantee, and
right.
You cannot win there.
Yes.
So
there will be the latency when you have a failed host in the placement group. When you have a new host coming up, it won't be close enough. So there will be latency between them. So is there a way you could?
There is no way.
Okay.
Only if you pay a lot of money and you get your own instances. But this is why you need to check your latency and to check your resources, the network throughput that you will get all the time.
Okay. What if you don't get it? Then you have to. What if you don't get the latency right within the limit of you need? Then you need to throw away the whole cluster. Is that how it works?
There is a utility VNet perf of Vertica, and it will give you the throughput and the latency, I think.
Okay.
So and you need to check every node, because if there is even one node that has a degradation in performance, all your queries and your ETLs will suffer. Even one node.
Right. Okay. All right. Thank you.
All right. Thank you.